Hello guys, welcome back to another problem solution video. Today we have yet another question here from the COMC 1998 contest. It's the fourth question, or the last question of part B. So, as always, let's first start off by reading the question. A line segment BC has length 6, and point A is chosen such that angle BAC is a right angle. For any position of A point D is chosen in BC so that AD is perpendicular to BC. A circle with AD as diameter has tangents drawn from C and B to touch the circle at M and N respectively. With these tangents intersecting at Z, prove that ZB plus ZC is a constant. Now here, I have already drawn out a graph for you guys to see, and I've added some color, it might be hard to see, and what you need to realize is that AD is the diameter, and then M and N are the lines from the center to M and N are just going to be labeled as R for radius. I have then also made it so that I've added some variables on the side. So BD is going to be A and DC is going to be 6 minus A because, well, BC, which is the sum of both, has to be equal to 6. And similarly, because these two lines, so BC and DC and MC, because they are both tangent and they're also both perpendicular to the radius of the circle, we know that these two are the same. It's just a formula. Now we know that this is 6 minus A, and this side also has to be 6 minus A. And similarly, on this side, we know that this side is also going to be A, because this side is A, and these two lines here are tangent. And so we'll just label this as X. We know that these two are also tangent, so this means that this one's also X. So now from here, we're going to use Heron's formula. Now, what is Heron's formula? Well, to put it simply, you need to find semi-perimeter, which is just the perimeter divided by 2, and then you can use that to solve for the area. So from here, we can see that the perimeter here, which is right as P, is going to be quite simple to solve actually. It's just going to be equal to all of these variables added together. So A plus X plus, in brackets, 6 minus A plus 6, and this is going to be equal to 2x plus 12. And so this means that P over 2, or the semi-perimeter, is going to be equal to x plus 6. Now that we have this, we can see that 1 over 2p times r, which is the radius, is going to be equal to Heron's formula. But I'm going to pause on this. I'm going to pause on this now. Why do we have 1 over 2p times r? Well, you can see here, if you're looking for the area, let's look at this triangle here. So, this one. What is the area of this triangle? Well, it would be r times BC divided by 2. Similarly, for all of these other three big triangles, so for example, Z, C, and the center of the circle, as you can see here, it's going to be r times ZC divided by 2, and similarly for this. Now, what is ZC plus BC plus BZ? It's just going to be the perimeter. So this means that the area of this entire thing is going to be the perimeter, which is the sum of all three of these sides, divided by 2 because we're solving for a triangle, and we divide by 2 for the area, times r, which is going to be height for all three of the smaller triangles in the bigger triangle. And now we'll say that this is going to be equal to the other way is always a bug. Sorry. Okay. He's blown out the window. Okay. Now that we have this, we're going to look at Heron's formula. Heron's formula is quite simple to solve actually. It's just going to be equal to the semi-perimeter, so this would be x plus 6 in this case. And this would be multiplied by the semi-perimeter minus one of the side lengths, in this case, which would be 6. And after that, we have to multiply this again by the semi-perimeter minus another side. So in this case, a minus x. And finally, we have to do that again. X plus 6 minus x minus 6 minus 6. It's getting pretty crowded there, and I have to extend this. And luckily, we could obviously just shorten this up and expand it and simplify it. So x plus 6 and 6 minus a, then multiply by a again, and we're going to put another square root over it. And you can finally solve for r. So pretty simply, you just move the 2 over r here, the 1 over 2p over there, and now we get r is going to be equal to square root ax times 6 minus a divided by x plus 6. And here we can further simplify this into r squared, so we're just going to get rid of the square bracket here because it's, not going to lie, pretty annoying. Ax 6 minus a divided by x plus 6. Now that we have this, we can also look at these similar triangles here. So, for example, CAD and ABD. These triangles are actually going to be similar to each other, and the reason why is because of their angles. As you can see here, they both have two right angles, and also one of the angles that they share. So, for example, this angle here and this angle is going to be equal. Added together is going to be equal to 90, and this angle here and this angle here is also going to be added up equal to 90. And as you see, these two angles from the two different triangles are also going to add up to be equal to 90, and so that's how you know that all three of these angles are going to be equal to each other. Actually, no, all six. Sorry. And this means that we can write out a similar triangle and use ratios. So we can see that triangle ABD is going to be similar. So I write this little squiggly sign to see that it's similar to each other to triangle CAD. And now, what sides are similar to each other? Well, I usually like to draw these little length lines. So CD and BD. So these are the ratios we're going to use. So in other words, BD is going to be ratioed with AD, and AD on the bottom is going to be ratioed with CD. So from here, we can see that it's just going to be equal to, well, these side lengths, and since we already know them in variables, we can write out to 2r over a, which is going to be equal to 6 minus a divided by 2r. And further simplifying this, we get 4r squared is going to be equal to a times 6 minus a. So what we did here was we just did a cross multiply, so this one multiplied by this one, and this one multiplied by this one. It's going to be equal to each other. So now let's look for ZB plus ZC. Now we can see here that ZB plus ZC, so ZB plus ZC, this is just going to be equal to a plus x plus I was going to look out of here, 6 minus a, and this is going to be equal to 2x plus 6. Now that we have this, something that we can actually do here is that now we can finally solve for this. So looking back to these two equations here, we have 4r squared is going to be equal to a times b minus a, and r squared is going to be equal to ax, 6 minus a, x plus 6. And now we can actually compare a times 6 minus a and this equation here, as long as we just remove the 4 here. So this is how we receive 4 underneath 6 minus a, and this is going to be equal to ax 6 minus a divided by x plus 6. And from here, we need to remove the 6 minus a from here on both sides and the a. So this means that this gets turned into 1 over 4 is going to be equal to x over x plus 6. Now here we multiply by the 4 and get rid of, and also multiply it by x plus 6 to finally receive x plus 6 is going to be equal to 4x, and hence x is going to be equal to 2. Because we know that ZB plus ZC is going to be equal to 2x plus 6, we know what 2 is, we know that ZB plus ZC is always going to be equal to 10, because x is always going to be equal to 2. Thank you guys for listening. If you have any other way to solve this problem, please let me know down below in the comments, and thank you guys for listening. Bye.